In the last 48 hours, a leak has emerged that suggests Google just launched a direct attack on Nvidia's most valuable asset. It's not their chips, it's their software. Nvidia's dominance in the AI hardware market is secured by CUDA. While alternatives like Google's TPUs have matched Nvidia on raw speed, they have suffered from switching costs. For Frontier Lab, moving from Nvidia to another chip usually requires a total rewrite of the code and months of engineering work. This is the barrier Google and Meta are now targeting with a project codenamed TorchTPU. The core technical problem for Google has been a difference in execution styles. Nvidia's GPUs use what's called a eager execution. When you write a line of code, the chip runs it immediately. That's why developers love it. It's intuitive, it's fast to debug, and it just works. Historically, Google's TPUs use lazy execution. Instead of running code line by line, the TPU would wait and record a long list of instructions before running them all at once in a batch. While this is efficient for large-scale math, it's a nightmare for developers. If you try to run standard PyTorch code on it, the system frequently stalls to figure out what to do next. These pauses, or graph breaks, can make even the fastest TPU feel sluggish compared to an Nvidia GPU. TorchTPU fixes this by introducing a native TPU backend. If you look at the technical documentation in RFC 9684, Google is essentially teaching the TPU to act like an Nvidia GPU. It implements a new mode that allows TPUs to handle code eagerly, meaning it executes instructions as they come in, just like CUDA. By integrating directly with PyTorch's latest compiler, it removes the friction that forced developers to stay with Nvidia. Now you can take code written for H100 and run it on a TPU with almost no modifications. The software bridge is being built just as Google deploys its most ambitious hardware yet, TPU v7 or Ironwood. Ironwood is a multi-chip design delivering massive compute power, 4016 teraflops. But the real breakthrough is how it talks to the other chips. Google is using the Optical Circuit Switching, or OCS system. Essentially, it's a system that uses tiny physical mirrors to route data along using beams of light, which drastically increases the speed. Traditional networking uses electrical switches that generate heat and slow down the data. Google's mirrors move the data at almost the speed of light with almost zero delay. This allows two things. The first is massive scale. This allows Google to link almost 9,000 chips together to act as one single giant processor. Nvidia's standard system usually max out at 72 or 576 GPUs before they have to use slower networking. Second is the lower cost. Because mirrors don't use as much electricity, the total cost of ownership for an Ironwood cluster is estimated to be 44% lower than Nvidia's latest Blackwell chips. The industry is already shifting. Anthropic recently committed to a deployment of 1 million TPUs, and reports show OpenAI is using the threat of switching to TPUs to force Nvidia to lower their prices. For the first time in a decade, their software barrier is falling. When the code becomes portable, the only thing that matters is who has the cheapest, fastest, and most available chips. As TorchTPU hits production in 2026, Nvidia will have to compete on price, not just because they were the only option.